Hey guys, what's up? See, I'm here with your next topic, and what this evening topic is about the Fischer structure, and this is going to be a short lecture. Well, I'll be describing two of the very important structure of the glucose. Where these two structures are in equilibrium with each other, and there is a way to represent, and that's why it is called Fischer structure. It's very important, but it's because related to the hemiacetal development. So you're going to like it. You're going to get it related with the very previous lecture I did, right? In case you haven't watched it, go back. After you have watched this one, or you can go and watch that first, and then you can come back to watch here, right? So this is about the Fischer structure. But in order to do so, I have to draw the hemiacetal development in the glucose, and that's going to be like this. See, in the hemiacetal development, or what I'm trying to do, what you need a vertical line, right? And this one has a double bond. This one has a double bond oxygen and a hydrogen. This is your first carbon here, right? Now the next carbon here is having OH on the right hand side. This third is having OH on the left hand side. Hydrogen is on the right hand side there. Hydrogen is on the left hand side. This fourth one is again all the other carbons in the chain has their OH on the right hand side, right? So the 1, 2, 3, 4, 5 and 6. So there is no need to have here. So this last one is in the form of CH2OH, right? I've already described that this last one and the first one, these are not chiral, only these four are chiral, so these are very important. So you have H over here and you have H again over here. So how the structure is developed, the cyclic one, what happened, this oxygen bind itself with the carbon here, and then this proton, after it is released, it goes to the oxygen, right? And due to that you get your first structure, and that first structure is nothing but this one. What you have to do, you have to place again a vertical line, right? You have to draw a vertical line again. I hope it's straight, right? And this very first one is now in the form of OH. The very first one is now in the form of OH. But what I'm doing OH on the left hand side and H on the right hand side, because this side I'm drawing the beta D glucose structure, where the first alcoholic group is on the left hand side, right? And then so this OH is on the left hand side and remaining is nothing but as usual. So you have your OH here, right? You have again your H here, and this OH is right here on the left hand side. There you have your H again. This fourth one is again OH, and there you have your H, and this fifth one is having OH on the right hand side, and the last one, this very last one is nothing, is not changing at all. So this is in the form of CH2OH. So what you need to concentrate while you draw the Fischer structure, that if it's talking about the beta structure, if it's talking about the beta structure, then the OH must be the OH formed due to the hemiacetal development. It must be on the left hand side, right? And all other things are exactly the like you have in the open structure of the glucose. So this is the beta D glucose here. Now draw the alpha one. So I'm just naming it first and then I will draw. So this is your alpha D and glucose, alpha D glucose. So what is happening here? You have again your vertical line. You need to draw a vertical line here. And this very vertical line, first one is having OH on the right hand side, H is on the left hand side, and this one is having nothing but a CH2OH, and then you have your second one, there is nothing going to change, so all other things will be remaining as usual it was. So OH, H here, right? Next one is again H here and OH right there. And then the next one again is having OH on the right hand side, H on the left hand side, and the last one is also having OH on the right side and H on the left side. So this structure is called alpha D glucose, while this structure is called beta D glucose, and this entire representation is called Fischer structure of the glucose, right? I hope I tried to make you go as simple as it could be, but in case you have problem understanding how this hemiacetal development exactly took place, then you need to you definitely should go and watch out the very previous lecture. That's definitely going to help you out, and this is going to be quite an easy way, all straight through your mind, right? So I have to wind this right here. I will say thanks for watching, take care and good night.